Hello students, welcome back to the video lecture series of engineering graphics. In the last video we completed drawing number 2 and then I gave an introduction for projection of straight lines. In projection of straight lines we discussed the position of a line. We discussed 5 positions of a line, starting from position 1 to position 5. And in all the positions, the line was kept parallel to either HP or VP. And then it was made inclined to or perpendicular to the other plane. For example, if the line was kept parallel to HP, it was made inclined to VP and perpendicular to VP. So, we did 5 positions. Now we are coming to the last position, the ultimate position, where the line is inclined to both HP and VP. Okay? And usually the problems are asked only on this case. Those 5 positions were discussed, to facilitate your understanding for this position. The position of line inclined to both HP and VP. So now we are moving on to drawing number 4. Drawing number 2 was on projection of points. Drawing number 3 is an assignment to you. Now this is drawing number 4. Under drawing number 4, I think you have 5 problems. Okay. So let us see what we can do in this video. How many number of problems can we complete in this video? Let us see. The problem goes like this. The problem number is 2.2.1 as per the CMRT question bank. This 4 is the reference number from the VTU question bank. Okay, let me read out the problem for you. A line AB, okay, so the ends of the line should be A and B, has its end A 20 mm above HP, okay, and 15 mm in front of VP. You have already learned the projection of points, so you will be able to draw the projector of A. It is 20 mm above and 15 mm in front of. It can't be below HP here, it can't be behind VP here. As I already mentioned, you are now in first quadrant, so the point has to be above HP and it has to be in front of VP. There is no other option, okay? Because we are going to get the top view of the line below XY line and front view of the line above XY line from now onwards, starting from projection of straight lines. So that is fixed. Similarly here, B is 60 mm above and 45 mm in front of VP. So you are given the position of both the points A and B with reference to VP and HP. So you can draw 2 projectors, one for A and the other for B. Now if you want to draw 2 projectors for A and B, what should be the distance between these projectors? Is what is given here. The distance between the end projectors is 70 mm. The distance between the projectors of A and B, okay, is 70 mm. So having given that, you are asked to draw the projections. You have to draw the orthographic projections for the line AB. Okay. So you need to locate the points A and B first, then connect them so that you get the top and front views of the line AB. Then let us see what is to be found. Let us draw the projections of line AB first. You are asked to find something, determine the apparent lengths and true inclinations. So this is the problem. Okay, let me start the problem now. We are going to draw an XY line. You are following first angle projection, so it is important that you write this notation, VP and HP. Okay. Now let me mark the point A. Point A is 20 mm above HP, 15 mm in front of VP. So this is A dash, this is A. This distance has to be 20 and 15. 20 mm above HP, 15 mm in front of VP. Done. So when you are doing it on your sketchbook, this has to be a thin line. The projector is also a thin line. The dimension line is also a thin line. Okay. Now, where is the projector B? It is given that the distance between the projectors is 70 mm. So from here, you can use your scale or compass, mark 70 mm towards the right. Okay, and then you can draw the projector for B there. What is given about B? It is 60 mm above HP, 45 mm in front of VP. So I am drawing a line here equal to 60 mm. This is front view of B, 60 mm above HP, 45 mm in front of VP. This is B. Let me mark the distances. But while marking the distances, I mark them a little away by extending the lines. These two are extension lines. You will know why I have drawn them far away once I complete the problem. So this is 60 and this is 45. And of course, this distance is 70. So this is what you are given. Okay. So far, all the lines that we have drawn here are thin lines. Okay. So you can manage the pressure with which you are drawing on your sketchbook and then draw them as light lines. Of course, you are going to use the same pencil to draw the dark line as well as light line. So this is the front view of A and this is front view of B. When I connect them, I get the front view of the line AB. This can be made dark. This line has to be dark. Similarly, if you connect the top view of A and top view of B, you get the top view of the line AB. This also will be made dark. So we call these two lines as the projectors of the line AB. Okay, or orthographic projections of the line AB. This is the top view of the line AB and this is the front view of the line AB. I could get these things with the given data. So whatever is given, I have drawn now. Okay. So only this line and this line should appear dominating once you complete this part of the problem. Once it is done, now let us see what is to be found. You are asked to find the apparent lengths of the line. These are nothing but apparent lengths only. These are not true lengths. Okay. When do they become true length? You know the true length principle. If the top view of the line is parallel to xy, this becomes true length. If the front view is parallel to xy, this becomes true length. None of them are parallel to xy line, so none of them are true lengths. In other words, both are apparent lengths. Since you are asked to measure them, you can measure them and write by dimension. Now, when you use your software and draw these lines, A dash B dash should come to 80.62. So I am just marking here for your reference so that when you practice in the lab, you will know that it has to be 80.62. Even our software has an accuracy of 0.01 mm. In other words, the least count is 0.01 mm. So you will be able to measure 80.62. It should not be 80.61 also in the software when you use your software. Okay. Then one of these dimensions I got, and AB should be 76.16. So let me measure this also. This has to be 76.16. You need not write mm. Okay. Of course, since you are asked to measure them, you can make the statements here. A dash B dash is equal to 80.62 mm. Similarly, AB is equal to 76.16 mm. So that part of the problem is completed. Okay. So the apparent length is done. Now true inclinations. What do you mean by true inclinations? Inclination of the true length with HP and VP are called true inclinations. Inclination of the true length, in other words, inclination of the actual line with HP is denoted by theta. Inclination of the line with VP is denoted by phi. This was already given to you in my last video. So your first aim is now to find the true length. Okay, both are apparent lengths. You have to find the true length, but none of them are parallel to xy. So you can't use the true length principle here. I am not able to use it. Now, this is the line which is inclined to both HP and VP. This is the last position, position number 6. This is an example of that. As soon as you look at this, I can say the line is inclined to both HP and VP. Is it not? Because the top view is inclined to XY. That means the line is inclined to VP. The front view is inclined to XY. The line is inclined to HP. So it is inclined to both HP and VP. When that is the case, how to find the true length? Let us see now. Now, I want to make use of the true length principle. If I want to make use of the true length principle, I have to make one of the views parallel to XY. Okay? So either the top view or the front view should be made parallel to XY so that its projection becomes true length. My aim is to find the true length. Okay? So what do I do is, go to A, passing through A, draw a line parallel to XY line. This should be a thin line. Okay? Now use your compass, take A as center, AB as radius, draw an arc onto the line drawn. This is B, it has moved to point B1. Okay? So this line and this line are equal in length. In other words, AB is made parallel to XY. The length remains the same. The length is 76.16. So you are using your compass, A as center, AB as radius, you have drawn an arc so that AB is made parallel to XY. Now let us project this in the front view, to the front view. I didn't disturb the position of A, so A dash will remain there only. I have moved B to a new location B1. So correspondingly, B dash also will move to a new location in the front view. Okay? So where does it move? I can find it by drawing a projector from B1. Okay? I can call this line as locus of B. Locus of B means the point B can move along that line. That line is drawn parallel to XY. Okay? So even here, I can call this as locus of B. Locus of the actual point B. So don't write a locus of B dash and all. So what was I telling you? As B is moved from B to B1, correspondingly B dash also will move to a new location. And that location you can get by drawing a projector from here, in this direction. So this point is denoted by B1 dash. So B dash has moved from B to B1 dash. That is its new location. Now, if you connect this A dash with B1 dash, that becomes the true length. The true length has to be made light. Please remember, true length should be drawn light. This line should be dark and this should be light. Done. So you got the true length. We have used the true length principle here in fact. Okay? Because the top view is parallel to XY line, its projection should be true length. In other words, the front view should be true length. So this is the true length now. But you are not asked to measure the true length, you are asked to measure the true inclination. So you can measure this angle. Inclination of the line with HP is denoted by theta. Okay? So theta is equal to, let me give the angle, it should come to 28 degrees. When you measure that angle, it should come to 28 degrees. So I will also write down here, theta is 28 degrees. Got it? Let me repeat the procedure once again. This was the original position of the top view. I want to make it parallel to XY to get the true length in the front view. So what did I do? I took A as center, AB as radius. I have drawn an arc till here, and I have drawn a line parallel to XY line here. So AB is made parallel to XY. Its new location is AB1 now. If AB1 is parallel to XY, its projection should become true length. So for that, what did I do? I have drawn the locus of B and then projected B1 and got the position B1 dash. Once you get B1 dash, connect A dash and B1 dash, you get its true length. And then you can measure the angle theta. Now, getting phi is easy now. Inclination of the line with VP is quite easy because I already got the true length. This is the true length. So you can use your compass, measure the true length with the compass. Okay. Whether you draw the true length here or here, it is the same wherever you draw. There is no change in true length. So what do I do? Take A dash, B1 dash as radius with compass, A as center, cut the locus of B. Let us say A dash, B1 dash is equal to some 100 mm. So take 100 mm as radius, A as center, cut the locus of B. Let us say it is coming somewhere here. Okay. So I will call this point as B2 because B1 is already done. Now I call it as B2. If you connect with A with B2, you get the true length again here. So A dash B1 dash is equal to A B2. That's important. Let me repeat again. A dash B1 dash is equal to A B2, which is nothing but true length. But you are not asked to measure the true length, you are asked to measure the true angle. So this angle has to be measured, phi. Inclination of the line with VP is called phi, and that should come to 20 degrees. Even if it is some fraction, even if you get some 20.6 or something, it will be rounded off to 20. So that is how you can complete this problem. It's a simple problem, okay? With the data that is available to you, you are able to draw the projections first, and from that you are able to find or locate the true lengths and then the true angles. Okay, phi is equal to 20 degrees. You have to write here. So what are statements you are making? Maybe in your sketchbook you can highlight them in a box. You can create a box and keep the solutions in a box. Okay. So that's it about this problem. Let us take the next problem. Okay. So wherever you find some doubts or some difficulty, you can rewind the video and see number of times. Okay, any number of times you can watch. Let us take the next problem. Let's take the next problem now. This problem is also on the case of a line inclined to both HP and VP. The problem goes like this. The problem number is 2.2.2 from the question bank, and problem number 2 from VTU primer. A line AB, once again it is line AB, 80 mm long. That means you are given the true length of the line. The true length of the line is 80. So let me state it here. TL is 80 mm. Okay. Then it is inclined to HP at 30 degrees. That is its true inclination. So I can write it as theta. Theta is equal to 30 degrees. In other words, the line is inclined at 30 degrees to HP. Then, and also it is inclined at 45 degrees to VP. So phi is equal to 45 degrees. So you are given the true length, you are given the true inclinations of the line with HP and VP, theta and phi. You are asked to draw the top and front views of the line and determine their lengths. That means you have to find the apparent lengths once again here. Okay. So having given the true length and true inclinations, you are being asked to measure the apparent lengths. In other words, we have to draw the top and front views of the line and measure them from the given data. And something else is also asked. Let us see after completion of the problem. So if you recollect, in the last video we found the true length and also the true inclinations theta and phi. Okay, we determined true length first. Since it was not asked, we didn't state it, but you were asked to measure theta and phi, we found them. So in this case, it is just a reverse of the previous problem. You are given the true length theta and phi, and then you are asked to draw the projections. In the previous case, you were given the projections and you were asked to find the true length and true angles. It is a reverse of that. Let us see how to solve it. Some data is missing here. At least one of the ends position should be given. The end A touches both HP and VP. That is also there. So I didn't add it. The end A touches both HP and VP. So A is in HP and A is also in VP. So I can start with that. A is in VP, A is also in HP. Top view you draw below XY line, front view you draw above XY line. So accordingly I have marked the points, but it is the same point. Now let me draw the true lengths first. The line is inclined to HP at 30 degrees. So I am going to draw a line inclined at 30 degrees here and equal to 80 mm. 80 mm is the true length. This line will be drawn as light line. So 30 degree angle, 80 mm length. Because this is true length, I'll call this point as B1 dash, and also I draw its locus here. This is the locus of B. This is true length. I can show the dimension. I show it little away to avoid any interference. True length is 80. The angle is 30. Similarly, I can also draw the true length in the top view. This time the angle is 45. Phi is 45 degrees. So once again I draw a line equal to 80 mm length, but this time the angle will be 45. I'll call this point as B2. I can't call it as B because A dash B dash will be the front view, AB will be the top view. Okay, so for the true length we can use B1, B2 and so on. Because this is front view, I use dash. This is top view, I can't use dash, just B2. And as soon as you get B2, I can draw the locus of B. Just draw a line passing through that point parallel to XY line. And this length is also 80 mm. You can dimension it. When you draw these extension lines, make sure they are perpendicular to this line. Okay, and mark the dimension a little away. This is also true length, which is equal to 80. This is what you are given. Whatever is given, I have drawn here. Okay, you are given the point A is on VP and HP. You are given the true length as 80 and inclinations as 30 and 45. This is 45. Yes. Now your aim is to get, what is your aim? Your aim is to get the top and front views. In other words, you have to draw the projections. So as I was mentioning earlier, true length principle is very important. In each and every problem, we will use the true length principle. We use the true length principle in the previous problem as well. But here, I use it in the reverse way. Reverse way in the sense like this. Because the front view is true length, its projection should be parallel to XY line. That's how I use it. Okay. How do you use it? Because the front view is true length here, its projection if you draw should be parallel to XY line. Until where can you project it? A dash is here. So draw the projection till onto XY line so that the top view is made parallel to XY. A is here. So my aim is to make AB parallel to XY. You will get it on XY here because A is lying on XY. Okay. So that's how I am using the true length principle. Because the front view is true length, its top view should be parallel to XY is what I am using. Okay. So I draw a projector from B dash till here. Okay. I call it as B1. So thereby what are you getting? By doing this, I am getting the length of the top view. Okay. By using the true length principle, you are able to find out what is the length of the top view. But that is not its actual location. I could get the length of the top view. In the next step, I will be able to locate its position. Okay. In the first step, I got its length. Now I will locate its position. You know that this is the locus of B. So B has to lie only on this line. From this, you got the position of B1 here. So I need to transfer it onto this locus. Okay. So how do you do that? Maintaining the same length. Take A as center, AB1 as radius. Draw an arc onto the locus of B. Wherever it cuts, that will be B. Did you follow? As a first step, you got the length of the top view, but B cannot be here. It has to lie only on the locus of B. So I transferred B1 onto the locus of B. For that, what did I do? I took A as center, AB1 as radius. I have used a compass. I have drawn an arc in this direction. Wherever it intersects the locus of B, I located it as B. And if you connect A with B, you get the top view. The top view should be made dark. This should be a dark line. This is true length. The true length has to be light line. Once you get B, it's easy to locate B dash in the front view because B and B dash should lie on the same projector. And you already have the locus of B here. So to locate B dash, what do? From here, I draw a line or projector perpendicular to XY. Wherever it intersects the locus, that is B dash. B and B dash they have to lie on the same projector. They can't lie on two different projectors because it's just a point B, one point. Once you get B dash, connect A dash with B dash using a dark line. So these are nothing but the apparent lengths of AB. Apparent lengths means the top and front views. Sometimes the top view could be a true length, okay? But in this case, the true length is different, the front view is different. True length is here, the top view is here. So these are the apparent lengths. You are asked to measure them. Let me see what are the values. A dash B dash is 56.57. So when you measure this, this should come to 56.57 and AB is 69.28. When you are drawing this dimension, make sure that the dimension lines do not intersect with each other. That's the reason why I have taken it a little away. Okay. These two dimension lines shouldn't intersect. No, it is 69.28. So you are asked to measure, determine their lengths. I got it. There is something else left in the problem. Also measure the perpendicular distance of A and B from both HP and VP. This is the point B in the front view. This is point B in the top view. You are asked to measure the distances from XY. So these were the distances you need to measure. In fact, I don't have those values here, so I'll just write them as some X and Y. X and Y you need to measure and write down. Okay, X is the distance of the point B from VP, and Y is the distance of the point B from HP. Measure the perpendicular distance of A and B both from HP and VP. Okay, so you can measure and write them there. So let me write down the statements here. A dash B dash 56.57 mm. AB 69.28 mm. What is X and what is Y, you need to measure and write. Okay. And then you can highlight them in a box. So this is exactly opposite of the previous problem. Okay, having given the true length with the true angles, we were able to draw the projections. In other words, we were able to draw the top and front views, and then we have measured the distances. Okay, let us take up the next problem. Let's move to the third problem of drawing number 4. The problem goes like this. The problem number is 2.2.3. The reference number is 6 from VTU primer. A line PQ, this time the line is PQ, 85 mm long. That means its true length is given. So I have written here, true length is 85. Has its end P 10 mm above HP and 15 mm in front of VP. So the position of the end P is given to you. Okay, the ends are P and Q here. The position of end P is given to you. Then what else is given? The top view and front view of the line PQ are 75 and 80 mm respectively. So the length of the top view is given as 75 and length of the front view is given as 80 millimeters. Okay, this is what you are given. You are asked to draw the projections and are asked to find something. Let us draw the projections first. One important point here, whenever you have this combination, when you are given the true length, the top view and front view, we will start by drawing either the top view or front view parallel to XY. This is a very important point which you should know. Okay, when you are given a combination of true length, top view and front view, we will start by drawing either the top view or front view parallel to XY line. Why should this be adopted? Can you tell me? Why should I draw by drawing the top view or front view parallel to XY? This is to make use of the true length principle. Okay, this is to make use of the true length principle. Okay, so let us start with the XY line. First angle projection. Let us mark the point end P first. 10 mm above HP, 15 mm in front of VP. This is P dash. This is P. (10 mm and 15 mm). Yes, you have located point P. Now, as I said, either the top view, which is 75, or the front view will be drawn parallel to XY to start with. I am drawing the top view parallel to XY. The top view is 75. So here I am drawing a line, a thin line equal to 75, and I will call it as Q1. It is not Q, it is Q1. This is not the actual position of the top view. Just to start with, I have drawn it parallel to XY. Okay. So let me show its length. I will show it far away. This length is 75. Okay. Yes. Now comes the true length principle. Because the top view is parallel to xy, if I draw its projection, that should become true length. Okay. I repeat again, because the top view is parallel to xy now, its projection should become true length. And what is the true length? 85. So I am going to draw a projector from Q1. Done. Now take P dash as center and 85 mm as radius. Cut this using a compass. P dash as center and 85 is the radius. Cut it. That becomes Q1 dash. This is Q1, its projector should be Q1 dash. So this is your true length. True length will be drawn using light line. Let me dimension it. True length is 85. So you made the true length principle. You made use of the true length principle. As soon as you get Q1 dash, you can draw its locus. Yes. Now, what is the front view? 80. Take P dash as center, 80 mm as radius. Cut this. So that this is Q dash and this becomes the front view, which will be made dark. You can show its dimension. It is equal to 80. Yes, you got Q dash. So where should Q be lying? If you draw a projector, it should be lying on that projector. Okay. So through Q dash, you are going to draw a projector, and Q should lie on this. But what is its length? Length of the top view? It should be 75. This is 75. Okay. So Q1, which is here, has to be transferred onto this projector. But the distance, the length has to be 75. So take P as center, PQ1 as radius, draw an arc to cut this. This is Q. This is the direction. So connect P with Q, that becomes the position of the top view. Should be dark. This length and this length are equal. You are using compass. P as center, PQN as radius. You have drawn an arc to cut this projector. That's where you get Q. So these are the projections of PQ. This is top view of PQ. This is front view of PQ. Once you get the projections, you can find whatever you require. You are asked to determine the true and apparent angles. If theta and phi are the true angles, alpha and beta are apparent angles. The representation of the apparent angles is by alpha and beta. You know, theta is the inclination of the line with HP, phi is the inclination of the line with VP. Then what is alpha? Alpha is inclination of front view with XY. Similarly, beta is inclination of top view with XY. So this you should know. Okay. Now let us find the angles. Now already you have the top and front views here, so you can measure the angles alpha and beta. Alpha is 30 degrees, beta is 23. This is alpha, 30. This is beta, 23. Alpha and beta are the inclinations of the front and top views respectively. 30 and 23. Done. Now you also have the true length here. So the inclination of the true length is nothing but theta. Theta is the inclination of the true length with HP or with XY. This is theta. And theta should come to 28 degrees. You need to find phi now. If I have to find the angle phi, which is the inclination of the line with the VP, I have to draw the true length in this view. So how do you do that? Draw the locus of Q. You know the true length. True length is 85. Take P as center, 85 as radius. Cut this. You can call this as Q2. We have not used Q2 anywhere. So connect P with Q2. That becomes the true length. The true length will be a light line. And its angle will be phi, this angle. And that should come to 28 degrees. I'm sorry, 20 degrees. Okay. So we have measured the true angles as well as apparent angles here. Let me write down the values here. Theta is equal to 28. Phi is equal to 20, alpha is equal to 30, and beta is equal to 23. All the four angles have been measured. So when you are practicing this in the sketchbook, what I would suggest is you listen to the video till to certain extent. You stop the video there, complete that sketch, then move ahead and then complete the remaining part. That will be better. And in between, if you are getting any doubts, you can go back, rewind it, visit it, and then implement it. Okay. I got a very good feedback from the students saying that these videos are very useful. These videos were very useful. I think I'll be sending those feedbacks also to you. I have the feedbacks with me. So they have appreciated these videos last time. Last was the first time we have done these video lectures because of the COVID situation, and they were well received by the students. So with that we complete the third problem. Let us move to the next problem.